Okay, today we are going to talk about the properties of quadrilaterals. Okay, when we say quadrilaterals, we're talking about a four-sided figure. Okay, and a four-sided figure, the basic one, square, rectangle, probably also know parallelogram, trapezoid. Hopefully you've heard of a rhombus and maybe even a kite. So we're going to talk about originally the most general type of quadrilateral is the quadrilateral. It's four straight sides, trilateral, four congruent, or not four congruent, four straight sides that are connected. Looks something like that. That might be a little too similar to a kite. Looks something like this. Four sides. One specific type of a quadrilateral is called a kite. A kite is a figure that has two adjacent congruent sides. So those two are congruent and these two are congruent. Adjacent means they're next to each other. So they're going in order. Another type is called a trapezoid. Trapezoid is very different than a kite. We did the area of these the other day. So a trapezoid is a figure with one set of parallel sides. These little arrows here mean these lines are parallel. That is a trapezoid. A special trapezoid, known as a parallelogram, has two sets of parallel sides. So that's going to look like, forgive my inability to draw straight on this computer. So these are parallel. I'm using a double arrow on this one to indicate that those sides are parallel and these other two sides are parallel. So a parallelogram has two sets of parallel sides. That is a special trapezoid because the trapezoid guarantees I have one. There's another trapezoid called an isosceles trapezoid. With an isosceles triangle, you have a pair of congruent sides. With an isosceles trapezoid, the non-parallel sides are congruent. Oops. So here I've got these parallel sides, and then these non-parallel sides are congruent. There are two, so any properties, we're going to talk about properties later. So these are the definitions. When we talk about properties, any property of a trapezoid is also going to apply to a parallelogram and an isosceles trapezoid. With a parallelogram, two sets of parallel sides, you have a rectangle. A rectangle is a parallelogram that happens to have four right angles. Okay? So the rectangle, this little symbol here means right angle. Hopefully you all already knew that, but this little box in the corner, four-sided figure with four right angles. Well, it is a parallelogram. So every property that is of parallelograms also applies to a rectangle and to the rhombus. A rhombus has four congruent sides. Well, those four congruent sides all happen to be two sets of parallel sides. Does this have two pairs of adjacent congruent sides? Like the kite? Yes, it does. So a rhombus is also a kite. So every property of kites also applies to rhombuses. And finally, we end up with the most specific one, the square, which is a rectangle and a rhombus. So it has four congruent sides and four 90-degree angles, or right angles. Okay? So, here my general quadrilateral with its 4 points. I'm gonna put those 4 points to make it a little more clear. And here's some specifics. Now, everything below, a square has all the properties of rhombuses, rectangles, parallelograms, and trapezoids and kites. Isosceles trapezoid doesn't really go anywhere. So, I'm going to put on the next page some properties. So,
Can I sneak in for just a second?
hold on, I'm recording. Okay, sorry for that interruption. We're now going to talk about the properties of quadrilaterals. I'm going to start with the most general two, being the trapezoid. Okay? The trapezoid has almost no specific special properties. Okay? It just has one set of parallel sides. However, it's got two offshoots. I'm going to talk about the parallelogram. That's going to be the one with a lot. And the isosceles trapezoid. The isosceles trapezoid, that's the easiest one. The properties of it is its diagonals. Now, diagonals are these lines to the middle. They look about the same length. That's actually a pretty good drawing for this. So the diagonals, they are, because they look as not good enough evidence, but the diagonals are congruent. And we'll talk about proving that later. I'm going to do the kite next. For the kite, and this isn't a good enough drawing to show this, the diagonals are perpendicular, meaning they meet at a right angle. And I'm not sure how to write that out, but this diagonal between the adjacent congruent sides cuts the angle in half. There's my right angle symbol. And this cuts this angle in half. This other diagonal does not cut that angle. So the parallelogram is going to have a lot. So I'm just going to start writing them out. First one, opposite sides are congruent. That means they're the same length. Here's my parallelogram. These sides and those sides are congruent. Opposite angles are congruent. That means this angle is congruent to this angle. And these two angles are congruent. Third one, consecutive angles add to 180. 180 degrees. So I'm going to draw another parallelogram here and label my angles. A, B, C, and D. So that means M angle, that says the measure of angle A, that's the angle right here, plus measure of angle B equals 180 degrees. That's those two angles. All consecutive angles this applies to, plus measure of angle C equals 180. Measure of angle C plus measure of angle D equals 180. And measure of angle D plus measure of angle A equals 180. The next one is the diagonals bisect each other. Be fine, just be quiet. Okay, school's out, so it might get a little loud. So this means these diagonals here, this half is equal to that half. And this half is equal to that half. So keep in mind that all the properties of parallelograms are going to apply to the things below it. So all of those properties also apply to rectangles, rhombuses, and squares. Hold on, I'm making a video. Okay, sorry for the interruption. So we were looking at our hierarchy and knowing that all these properties of parallelograms also apply to rectangles, rhombuses, and squares. So we come back here, a rectangle, there's a couple additional properties for rectangles. So I've run out of room underneath, but a rectangle gets, it also, like the isosceles trapezoid, has diagonals that are congruent. So not only do the isosceles trapezoid, the diagonals do not cut each other in half. The parallelogram, they do. The diagonals on the rectangle are congruent. Now, with a rhombus, the diagonals are not congruent. But a rhombus is a kite, so the diagonals are perpendicular. And I can be a little bit more specific than the one diagonal bisects the angle. Both diagonals bisect their angles. So here's my rhombus. Sides are equal. And here's my diagonals. So both of these diagonals are bisecting these angles, which is different from the kite. The square has no additional new properties about it. So over here, these are the definitions. Kite, one set of or two sets of adjacent congruent sides on the kite. The property, then if it meets that, it will have perpendicular diagonals and the long or the diagonal between these, it's not always longer, will bisect each other.
You're talking to somebody or yourself?